This is the part 2 under molecular orbitals. We are in the part 2 of the video. Like I said each time we combine 2 atomic orbitals, we obtain 2 molecular orbitals. These are points. I'm intentionally writing it for you, so make sure you are jotting it down. Each time we combine 2 atomic orbitals, we would obtain 2 molecular orbitals, namely the bonding molecular orbitals and the antibonding molecular orbital. Note very well, this is our bomb I'm releasing here now. The anti-molecular orbitals are of higher energy level. So the anti-bonding molecular orbitals, they are the higher energy level more than the bonding molecular orbital. You're going to see it when we enter in depth into this video. If I do not explain it quite easy, slowly, the way I'm explaining it right now, when we enter the main thing, you will not get anything I'm saying. So pay attention. Now, molecular orbital involving the s orbital. You know, under the orbitals, we have S, P, D, F. We have done quantum numbers, so endeavor to watch it. And remember, we have the s orbital, the p orbital, the d orbital, and the f orbitals. Now, we're talking about the molecular orbital involving the s orbital. Now, for the sake of this Chem 130.1, note this thing very well. The number of orbital under this course on this level will not be more than p. So we will not be dealing with d and f under this molecular orbital in Chem 130. Now we are only going to be dealing with s or what? P orbitals. And under the energy level, we will not exceed 2. It's not as if we don't have molecular orbital for d and f, but those are advanced. Now, under the energy level, we will not exceed 2. I even wrote it here. In terms of orbital, we won't exceed the p, and in terms of energy level, we won't exceed 2. That is what you have to know. Now, the s orbital usually form what we call the sigma bond. From normal chemistry, we have the sigma and pi bond. And we said the s orbital forms what we call the sigma bond. Therefore, when writing molecular orbitals obtained by combining s orbital, we have a word, a sigma bond. Now, like I said, note, we focus majorly on 2 orbitals. Now, I'm going to write it down so that you understand what I'm saying completely very well. Now, you can see from the board that we said if you have an atomic orbital, for example, like this, plus another atomic orbital, what we get is molecular orbital, right? Good. Now, I want you to know something. Remember from when I was introducing this course, I said when atomic orbital of an atom are combined, they give rise to what? The molecular orbital. Now, for example, from electronic configuration, I remember, you know, we have 1s. This is easy. Forget the too much stuff. This is so easy. From the electronic configuration, when we talk about 1x, 2s, 2p, 3p, this is the same thing, just on they kind of change it. Now look at, we have 1s, which is 1 atomic orbital plus another atomic orbital. When they come together, they will give birth to what? The molecular orbital. And we said in molecular orbital, we are going to be concentrating on 2 things. One is the bonding molecular orbital. The other is the what? The anti-bonding molecular orbital. And we said that the s forms what we call the sigma word, bond. And if you want to, this is some formula for sigma bond under this course. This is formula for sigma bond, and this is the formula for what? Pi bond, right? Now, this is the bonding sigma bond is this, and the anti-bonding sigma bond, you put a star at the top. So this is the bonding sigma bond. This is the anti-bonding sigma bond. Please pay attention and note this thing very well. Now, if I want to write the molecular orbital for this, we have 1s coming together to have another 1x. If I want to write the molecular orbital for this thing, it's so easy. All you need to do is, of course, you can see that this will now be, let me print, this will now give us bonding 1x, and there's antibonding 1x. Under this molecular orbital, immediately you write the bonding sigma bond. You have to write the antibonding. As we progress, you understand what I mean. Calm down. Let's do this again. So you have 2x and 2p. Just be noting what I'm doing. Before you know, you will catch everything. And so if I want to write the molecular orbital for this, it is, remember, this is the S, and we say the S orbital formed what we call the what? The sigma bond. So the molecular orbital for this is bonding 2s and anti-bonding what? 2x. That is it for this one. Calm down, calm down. By the end of this video, you will be a professional in this. Just keep on noting the points I'm making, and before you know it, it will be like a child's play for you. Now looking at the board, we're going to talk about the combining two atoms that both contains 1s and 2x. So this is an atomic orbital plus an atomic orbital to give you molecular orbital. Now, if you have 1x, 2s plus 1s, 2s, and you want to form the molecular orbital, remember I said immediately you write the bonding pair, you must write the antibonding at its front immediately. And so if you want to write this, so the molecular orbital will now be 1x, sorry, it will be sigma 1x, right? The next thing is sigma anti-bonding, right? The sigma bonding pair and then the anti-bonding sigma, you now write 1x. Then the next thing, that means you are done for this. The next one is for you to do for this, right? And so this one will give you sigma 2x and anti-bonding sigma 2x. So that is the molecular orbital for this. When you're given two atomic orbitals and ask you to write the molecular orbital, this is how you write it. Remember, I started with the bonding pair, and this is the anti-bonding, and this is the bonding pair, this is the bonding, the sigma bonding, and this is the anti-bonding. So keep on noting the points. Like I said, immediately you write the bonding molecular orbital, you have to write the antibonding molecular orbital immediately. And I said that the antibonding molecular orbital is of the higher energy level. Please note these things very well. That is all for this video.